Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is 𝚂𝚊𝚗𝚞𝚊𝚗𝚞 and I'm going to present a topic that is fundamental in mathematics, that is root and radical. This topic plays an important role in algebra and serves as a foundation for understanding more complex mathematical concepts. I hope this presentation will help clarify the basic ideas and application of roots and radicals. Let's begin. You know, guys, what is the roots? Roots is inversion of exponentiation. For the example, in here, there are and the root of A equals B if and only if B to the power of n equals A. And the root of A is called radical expression or radical form because it contains a root. Next. For the next, the radical expression can be written in exponential form, powers with fractional exponents. For example, and roots of x equals x to the power of 1 over n. A number is said perfect square if its roots are integer. Example, 9, 19, 36, and 100 are perfect square, but 12 are not. In our example, the number we are looking for is number 4. It's 4 because 4 square is 16, the number we start with. Let's check if we multiply 4 by itself or 4 times 4 equals 16. Great, this is perfectly with the definition. But what are the parts of square root expression? Let's have a look. Parts of square root expression. A square root expression is made up of these parts. The first part is the index. In our case, we are looking for the square root, so our index is the number 2. We can also find the other numbers in index depending on the type of root it is. For example, if we see 3, it will be a cube root. Just so you know, sometimes there is no number where the index go. If we don't see an index, that always means that is a square root. So we can just imagine that it has 2 at the index. This thing right there looks like a box is the radical, which is what the represent of the roots. The number that we see inside the radical sign is called the radicand. Lastly, the result is called square root, which is great. Let's review: index, radical, radicand, and square root. Good job. Now that we know what a square root and the part that it make it up, we will learn what we can do with it. Let's take a look. We have a square tray with 25 cakes, and we want to know how many cakes are on each side. To find out, we have to think a number that when multiplied itself equals 25. There is a number squared that the result in 25. To calculate this number, we will take the square root of 25, which is 5. We know this because 5 squared equals 25. Let's check the result. The horizontal side has 1, 2, 3, 4, 5 columns, and the vertical side has 1, 2, 3, 4, 5 and rows. As you can see, there are 5 cakes on each side. If we square that the number, we get the total of 25 cakes on the tray. The square root is in simple form if A. The radical does not contain perfect square other than 1. B. No fraction is contained in radical. And C. No radical appear in the denominator of a fraction. For the example in here, root of 24 is not a simple form because we can write it as 4 times 6, where 4 is a perfect square. We can simplify the radical into 2 times root of 6. Now we have discussed about how to say radicals. Now we have discussed about how to say radicals if there are examples like this. The first is square root of x. Nah, square-nya di sini bisa kita baca, boleh enggak gitu. Jadi bisa kita baca dengan square root of x atau root of x. Oke, kedua, the second one is cube root of x of y. And root of z. The fourth or the last one is fifth root of x squared times y cubed. Or tulisan ini bisa kita tambahin dengan in bracket. Oke, jadi kita bisa lihat, so we can see the difference in here. The first one is square 2 di sini bisa kita ucapkan atau tidak gitu. Yang ketiga bisa pakai cube. Untuk yang selanjutnya pakai 4, 5, 6, 7 itu pakai th. Okay, for the next example is simplify this radical. For the example, there are the root of 72, so we can simplify like we can rewrite again. Root of 72 equals 8.485, or we can simplify in 72 is root of 72 equals root of 36 times root of 2. Root of 36 is 6 and root of 2 in here. Why? Root of 9 times root of 26. Root of 9 is 3 times root of 26. And the last is 3 times 26. Its conclusion, root and radicals are important concepts in mathematics that help us understand how to reverse the process of exponentiation. The most common root is the square root, but there are also cube roots and higher order roots. Those are expressions that include roots such as root of 9 or cube root of 27, simplifying radicals, performing operation with them, and understanding their properties are essential skill in algebra and beyond. Okay, thank you everyone for watching my channel. I hope you like this video. See you next time. Bye-bye.